Hello everyone, welcome to Chapter 3, Probability. I know it's a lengthy chapter, but here we are. We are going to look at the examples related to the counting principle we saw and probability that goes with it. So let's start off with the first problem. A company is planning its summer advertising campaign. The marketing team is planning to mail one of the different types of advertisements at random to their town's residents each week. They have the following types of advertisements ready. How many different possible ways can a resident receive in the mail? So we have weeks 1, 2, 3 and 4, and they're planning to send out each week at random to the residents. Okay, the big question here is, let me highlight it for you. How many different possible ways? How many? Remember, these question types can either ask for how many ways or can ask for probability. So you have to distinguish between the two. When they say how many ways, you can have plenty of ways. You have no restriction really. And you just have to compute the correct answer to it. But for probability, we do have restriction in that probability can only take values between 0 and 1 inclusive. So we have to be super careful in responding to the question correctly, or sometimes we may just miss out on it. When you look at this table, this reminds you of your tree diagram actually, because if you were to put in a tree diagram, you can see that I'll not take too much time in this, but you can see that it's week 1 goes up here. Okay, week 1 would be small brochure and poster. So that's your first tree beginning. And then for week 2, it could be postcard and catalog, right? And so on, something like that. So you think of the tree diagram here, but then remember they're asking for how many different possible ways. So we are going to use not the tree diagram, but we can go directly for the fundamental counting principle. And according to that, you have to see if these are independent, meaning you don't have one dependent on the other, like the conditional probability. So we have basically the number of possibilities to be the number of possibilities in week 1 times the number of possibilities in week 2 times that in week 3 and times week 4. So what we have here is we have 2 possibilities in week 1 times 2 possibilities in week 2, 2 in week 3 and 1 in week 4. Multiply these out, you get 12. So the answer is that there are 12 ways, or 12 ways that a resident can receive an advertisement in the mail. Check this out. The same company decided that they want each resident to receive one of the 8 different advertisement materials they produce each week, with no repetition. Okay. So there are 8 materials and they're going to send out one per week without repeating it, of course. In how many different ways might a resident receive the 8 advertising materials if they receive a new one each week? Right? So we have 8 different materials sent out each week, no repetition. So once again, I think of fundamental counting principle here, and what we see is that for the first week, so I try to put these kind of positions, okay, 1, 2, 3 and so on. So we'll come down here, okay. For the first week, excuse me, for the first week we have 8 options, right? 8 advertisements that are available. For the second week, sorry about that, for the second week we have out of the 8, 1 is already used, we can't repeat. So for the second week you have 7 advertisement options. Okay, first week, second week. So what this problem differs from the previous one in that there they made sure that there were only 4 weeks and they were trying to send out different advertisement materials. But here we don't have that restriction. So you see that now out of the 7, now we only have 6 for week 3 because we've already used 2 of these advertisement materials in the first 2 weeks. Okay, so So this will be week 4, week 5, week 6, week 7. Put in the wrong spot. Okay, and the last one goes out in week 8. So you have 8 materials and 1 per week. So you got that. So what do you see here? We see that it's a fundamental counting principle, which means you have to multiply them, right? And because of the way the sequence is set up, it's 1 less than the previous number each time. And we've seen what this stands for. This is nothing but your factorial, right? So we can say the possibilities would be 8 factorial, and instead of multiplying them out, which you can also do, you might want to use the factorial button. And if you recall, we said you have to first punch the number 8, okay, and then go to Math, go across to PRB, and go down to option 4, which shows the exclamation mark, and hit enter. Okay. So the screen will now display 8 with the exclamation mark, meaning 8 factorial. So hit enter again, and if you hit enter, that gives you the value 40320. Again, as I mentioned, you could find this information by multiplying 8 times 7 times 6 times 5. But you can see that's cumbersome. So if you recognize the factorial situation there, it's better for you to use the calculator on that. In our next example, George will be taking 5 classes: algebra, world history, psychology, political science, and chemistry, and would like to know how many different ways he can order his class schedule, given that his school offers 5 time slots for classes each day. Assuming there are no constraints and each class can be taken in any time slot, how many different ways can George order his classes? Well, we have 5 time slots for these classes. So 1, 2, 3, 4, 5. 5 slots, right? And he can choose any class, isn't it? Each day. So in the first spot, we have 5 classes that he can choose, right? So 5 classes. The second slot, he only gets to choose from 4 classes because he's already chosen one of the classes in the first slot. In the third slot, he gets to choose from 3 classes. Fourth slot from 2 classes, and the last one, of course, goes into the 5th slot. And by fundamental counting principle, you multiply this, but as you can see, this is 5 factorial, so you can use your calculator, and that comes out as 120. So there are 120 possible ways to order the 5 classes. In our next problem, suppose a bag of colored marbles contains 10 marbles. If you draw 1 marble at a time from the bag without replacement, how many different ways can you draw all of the marbles from the bag? So we're trying to draw these 10 marbles one at a time. And the key is that we are doing it without replacement, which means when you pull out a marble, it doesn't go back inside. So we have the first slot, we have 10 marbles available, right? And you're taking it and putting it aside, then you go for the next one. So you have 9 to choose from. 8, 7, 6, 5, 4, 3, 2, and 1. Meaning you've pulled them all out, one by one, right? So in the first draw, you had 10 marbles to choose from. In the second draw, you had only 9 to choose from. Third, only 8 to choose from. This is 10 factorial. I'm just going to leave it in the factorial notation. If they ask for the number value, go ahead and use a calculator to compute it. So I just want to say this is without replacement. I just want to give a little twist to this problem and say, if it was with replacement, what does that mean? With replacement would mean that in my first option, I had 10 to choose from. Okay. In the second option, I still have 10 to choose from because I returned that marble to the bag because it's with replacement. So if it is with replacement, you notice that it's 10, 10, 10, 10, and so on, right? So that is how we understand the difference between without and with replacement. So the next problem says, 7 city buses arrive at the bus garage around the same time each night. In how many ways can the buses return to the garage first, second, and third? Okay, so if they didn't indicate first, second, and third, and they just said how many ways can it arrive, right? That would simply mean 7 factorial ways in which the bus can arrive. The 7 city buses can arrive, right? Because the set has 7 buses in it, so there are 7 factorial, which is 5040 ways for the buses to return to the garage. But then here we say 7 city buses arrive at the bus garage around the same time. And how many ways can they be returned first, second, and third? Right there we see that the order matters. Okay. Because of the ranking. Okay. Meaning if bus A comes first and then bus C comes next and then C arrives, that arrangement is different from having C, then A, and then B arriving. So the order matters here. That means we're talking about permutations. So what we're trying to do is, out of the 7 city buses, we're trying to see or choose 3 buses that arrive in a particular order, right? So then we go with 7P3. As per the formula, if you were using the formula, it will be 7 factorial over 7 minus 3 factorial, which is 7 factorial over 4 factorial. Okay. I'm going to show it to you manually because we know how to do it on the calculator. We'll also do that. When you do it manually, sometimes it seems tedious here, but try to expand it as 7 times 6 times 5 times 4. Then you have times 3, 2, 1, which is the same as 4 factorial, right? So what we do is we try to match it with the denominator factorial so that you have a way to cancel it off. So you just have to multiply the 7 and the 6 and the 5. Okay. Again, this is a little bit of work for us to do that multiplication too, but it's not that bad, right? So you get 210. Now let's do the same thing using the calculator. So in the calculator, you'll have to first punch in 7 and then go to Math, PRB, and this is NPR, so choose the second option. And what happens is it returns to the blank screen where it says N7 NPR. So now it blinks at a spot. There type 3 and then hit enter. So 7 is your N and R is your 3. So when you hit enter, it gives you the number 210. So that's a quicker way to, of course, use your calculator and get the answer. So what this means is that there are 210 different ways to select the top 3 buses to return to the garage out of the 7 buses. So you can see I just wrote that there, what I just mentioned. Let's go to the next problem. If 9 friends are going to occupy 9 seats in a shuttle on the way to the airport, how many different ways can they arrange themselves in the shuttle? Right? So, we understand that the order matters because, they're choosing to sit in a particular spot. So, friend A sitting next to friend B is different from, that order will be different from the friend B sitting next to friend A because we don't know who's going to be on the other side and so on. So we have 9 as our N because that's the total number of friends, and they want to be arranged in 9 different ways. R is also 9. Okay, so NPR would be 9PR. I'm saying 9P9. You must be curious to see how this looks on your calculator, so you can pause it at this point and then go check it out. If you're using the formula, it's 9 factorial over 9 minus 9 factorial, which is 9 factorial over 0 factorial. If it's just 0, you know, in math, that's really problematic. It means it's undefined. But 0 factorial is defined to be 1. So this is the same as 9 factorial. So if you computed this, you would have 362,880. So there are 362,880 different ways for the 9 friends to arrange themselves in the 9-seat airport shuttle. So a child randomly selects 5 toys from a bin containing 3 bunnies, 5 dogs, and 6 bears. How many different ways can the child select 5 toys? So you can again see that it is selecting our items out of n items. So we see that idea. That's the definition for both permutation and combination. The difference was that in permutation the order matters, in combination the order does not matter. So we can see that we have to use one of the two, permutation or combination. Which one can that be? So come back to the problem and kind of analyze it to see if the order matters. And clearly the order doesn't matter, because actually the child randomly selects 5 toys, and there are these options. So how many different ways can the child select 5 toys? Because it could end up that the child selects and all of them turn out to be dogs, all of them could turn out to be bears, right? So it doesn't matter in what order they appear. So if the order doesn't matter, then we don't have to duplicate the order, right? So meaning a bunny, dog, a bear, dog and a bunny. If you switch the order, it still doesn't matter, because the child just wanted 5 toys. So we have n as what is n? N is the total number of toys that are available. So we have 3 bunnies plus 5 dogs plus 6 bears. The child has a total of 14, right? 14 toys to choose from. And he wants to choose 5 toys. And because there is no order doesn't matter, we go with a combination. So that's going to be 14C5. In the previous example, I just remembered that I planned to show you how to do it on your calculator for this one. So I'm going to do that here for NCR. It'll be the same process. You just have to use NPR if it's a permutation problem. Alright, so for this one, what we do is we're going to do the 14. First punch in 14 and then go to Math, PRB, and we choose the third option, and then go ahead and hit enter. So we'll have 14 NCR, and then you have that number blinking. So go ahead and do the enter the 3. And sorry, not 3, it is 5. 3 was for the previous problem. And then you hit enter. That gives you 2002 ways. So again, remember, these are the number of ways that we are trying to number of ways that the child can select 5 toys. When we talk about probability, remember the answer should be between 0 and 1. Alright. In the next example, I'd like to show you how we can sometimes use a combination, multiple combinations in a problem where you will use multiple accounting principles to solve a problem. So here we might be called to use the combination principle along with the fundamental counting principle and so on. Let's read this problem. 2 companies send representatives to an industry conference. The first company sends 15 reps and the second company sends 18 representatives. Only 23 will be given the chance to make presentations. How many ways can 11 reps be chosen from the first company and 12 reps be chosen from the second company? Let's try to analyze this here. So the first company has a total of 15 reps and they want to choose 11 out of them. And in the second company, we have a total of 18 reps and we would like to choose 12 out of them. Right? And does the order matter? There is no ranking here, right? So we don't have any specific roles for them that they rank in such a way that it matters who will be in that role. Because of that, this is going to be a combination problem. So NCR, both places. That will be 15C11 and this will be 18C12. What we see is if we want to, and choosing from company 1 and company 2, they are two different companies, so they are independent, right? So to find the total number of ways, we can use the fundamental counting principle, which says multiply. If you want the total number of possibilities, multiply the number of possibilities from the first process times the number of possibilities from the second process. So fundamental counting principle says I'll multiply this first company's outcome times the second company's outcome. So what we do here then is for the total possibilities, you do 15C11 times 18C12. Now because we're using the calculator, it shouldn't be that tedious. So go ahead, take a moment, you can pause the video at this time and do the calculation yourself. As you can see, I have computed them separately and I multiplied it out. That's a huge number. So we'll say, so there are this many ways to choose 23 representatives with the 11 from first company and 12 from the second company. A swimming team has 15 members. The coach wants to create teams of 4 swimmers to compete in the relay race. How many different teams of 4 can she make? So once again, we don't have any issues with the order. So the total number of members is 15 and we want to create or draw 4 swimmers. We want to see how many such teams of 4 can we make. So this, because the order doesn't matter, we'll go with 15C4. Go ahead, compute it. Oh, that is 15C11. I thought I'll use the same answer. Okay. So that comes out to be 1365. Look at that, I had a hunch somehow. Interestingly, it does match with the 15C11. Very interesting. Alright, so we have 1,365 different ways of creating relay teams of 4 swimmers out of the 15 total swimmers. If all the swimming made you hungry, here we go to a sushi restaurant which makes 10 types of sushi rolls each day. They also offer 6 sashimi plates. A popular combination platter at the restaurant allows the customer to choose 3 different types of rolls and 3 different types of sashimi plates. What is the notation for calculating the number of possible combination platters that can be made? Okay, so we have 3 different sushi rolls from 10 types of rolls, right? So we have, let me write here, 10 sushi rolls. That's how many we have in total. and we can choose up to 3 rows. That will be your R. That's one thing, that's one type. And then we have the sashimi plates. So we have 6 sashimi plates, out of which we want to create 3 different plates, which is your R. So similar to the previous problem, this would be 10C3 and this will be 6C3, and we're going to multiply these two because they are independent of each other, but the combination platter allows them to choose 3 from here and 3 from there. And so the fundamental counting principle in combination with the combination principle gives you 6, you can just write this 6C3 times 10C3, or the other way around, doesn't matter, it's multiplying, right? They just wanted the notation, they didn't want us to compute it, so we will leave it like that. There are 6 runners in a race. How many ways can the runners finish first and second? Okay, your clue here is again first and second, which indicates order or importance to priority. So that means order matters. If order matters, we know we have to do the permutations. For permutation, we need to find out what n is. So the total number of runners is 6, out of which we want 2 of them to finish first and second. And how many ways can they do that? So that means we're going to do 6p2 npr, and then that answer will come out to be 30. Use your calculator. 30. So you'll see there are 30 ways. You always have to interpret it. Sometimes I don't do it in the lecture just because it takes more time, but understand that that's the way we will respond to the question. There are 30 ways of choosing the top 2 finishers. From a group of 6 runners. Let's take a twist in the same problem. There are 6 runners in a race. The first and second finishers will get a prize. How many different ways can the runners earn a prize? So you see the first and the second, and in your head you're thinking, yes, that looks like priority. But that was not the question. That was that was one of the data in your question. But the question actually says, how many ways can the runners earn a prize, not how many ways can they come first and second. So if they earn a prize, it just means that they have to come first or second. It doesn't matter. So say out of the 6 runners, runner A comes first and runner B comes second. They both are earning a prize. So that is the same as if runner B came first and runner A came second. Because we really don't have to distinguish who came first and who came second. We just want to know who got a prize. Because of that, this problem suddenly changes into a combination problem. So this means order does not matter. Okay. So A and B earning a prize is the same as B and A earning a prize. So A will earn a prize whether they come in first or second, right? So I'll just write there. A earns a prize whether he comes first or second. When I say A, I mean runner A. Okay. Because order doesn't matter, we know this is a combination problem. The total number of runners is 6, and you want 2 of them to finish first and second so that we get a prize. So NCR would be 6C2, and that makes it 15. So here again, we can say there are 15 ways in which the runners can earn a prize. Now we are going to compute probability. Okay, we've been looking at the number of ways. So we had like these crazy number of ways, right? A million number of ways, thousands of different ways of doing things. But now when we compute probability, we want to remember that our answers can only be between 0 and 1, which means we usually write a proper fraction if you present your answer as a fraction. Now, once again, let me recall that probability is the relative frequency formula, the theoretical probability formula. It all says that the probability, like P of A, remember P of A, something like that, is that we find the number of ways or number of possibilities of an event. Probability of an event, the number of ways the event can occur, divided by the total number of that are possible. This is how we write our probability. That's the fraction that gives us. Now our question is we just learned how to find the number of ways. We just have to use that in this fractional setup when we want to find the probability. So let's go about this problem. A store has 8 cellular phones and that 3 of those are defective. Find the probability that a couple purchasing 2 phones receives 2 phones that are not defective. Okay, so what are we trying to find? Translate this to our problem. So probability of, what's the probability that the 2 phones are not defective? It's a detective. Have you watched the show Monk? It came several years ago, decades ago I think, and he's a brilliant detective, but he has some OCD tendencies, so they call him the defective detective. So I think that's why I got it mixed up. Okay, so what's the probability that the 2 phones are not defective? That means we have to find the number of ways to select 2 phones that are not defective, because that is what we desire, right? So how many ways can we select 2 phones that are not defective, divided by the total number of ways to select 2 phones. That makes sense because the total number of ways to select 2 phones does not indicate whether they are defective or not defective. It's just the ways to select 2 phones. Okay. So if you think about this, the number of ways, number of ways would mean, I'm selecting 2 out of the 8 phones, right? So we have to think about permutation or combination. So do we have any order here? Does order matter? Clearly it doesn't matter what order the phones are taken, it just matters that they're not defective. So the order doesn't matter, which tells me that we can use the combination. So let's focus on the numerator, number of ways to select 2 phones that are not defective. So if you actually look at the phones that are not defective, I would like to draw your attention to this first sentence. 8 phones are there in the store and 3 are defective. Right? So how many are not defective? 5. 8 minus 3. The remaining 5 are not defective, right? So we have 5 phones that are not defective. So I'll just say 5 phones out of the 8 are not defective. And out of those 5, we will choose 2, right? Because it's among those non-defective ones that you want to choose. 5 out of the 8 are not defective, and we choose 2 phones from it. And for the denominator, if you see, there was no question about defective or non-defective. So the store has a total of 8 phones, and we choose 2 phones out of it, 2 from it. This, writing it in words, helps you to then formulate your structure for the combination. So we have 5 phones, that is basically 8 minus 3 good one, 3 bad ones. So we have 5 good ones, so that's 5C2. We're trying to draw 2 out of the 5, divided by 8C2. We're trying to draw 2 out of the total 8, and we're setting up a probability. Therefore, go ahead and compute this. You will get 10 out of 28, which would be 5 out of 14. It's a proper fraction, so you know you got your fraction right. At least it's an acceptable probability. So the probability of choosing, let's go back to the question. The probability that a couple purchases 2 phones that are not defective is 5 out of 14. Okay. So a class of 25 students has 12 boys and 13 girls. If a random group of 5 students is selected, what is the probability that they will be all girls? It's a good time for you to pause the video and try it on your own, come back and check. Okay. I'd like to set up my probability that a random group of 5 will all be girls. That's what I need to find, right? What's the probability that a random group of 5 will all be girls? So I want to write the formula for that. Remember, that's the number of ways we can select 5 who are all girls. Okay. So I want to take you back here, the same idea. Okay. Number of ways to select 2 phones that are not defective, right? Like that, number of ways to select a group of 5. With all girls, divided by the number of ways to select a group of 5. Doesn't matter if it's a boy or a girl. For that, I go to the problem and I say, okay, so there are, out of the 25 students, there are 13 girls, right? So out of the 13 girls, you want to create groups of 5, because that's how you can get the desired group of 5 with all girls for the numerator. That's a number of ways. The question is not the number of ways, the question is the probability. So we find the number of ways first to answer the probability. So the number of ways would be that there are 13 girls and 5 are chosen, divided by there are totally 25 students, boys and girls, and 5 are chosen. Okay. Here again, we want to decide if it's a combination or permutation. Go back and see if there was any ranking, any order that mattered. No order, so order doesn't matter. We go for combination. So that will be 13C5 divided by 25C5. Go ahead and do the computation. It comes out as 1287 divided by 53130, which is 0.02422. You can leave it as a fraction there, but if you wanted to really see what that could be in terms of percentage, it's roughly 2.4%. Okay, so that's the probability of getting all girls. So the probability of selecting a group of 5 which is all girls is 2.4%. There's a 2.4% chance of selecting a random group that has all girls. So class, I hope you had fun in this section, and we are done with chapter 3 officially. I will see you in the next video where we'll look into chapter 4. Have a good one. See you soon.